Good afternoon. Thank you very much for coming to my talk. So yes, the title on the agenda is Automate Yourself Out of a Job with Roslyn, which gets people to come in, and then you find out that I'm not actually going to teach you how to do that. So what I am going to teach, and then the title that's on the slide is Write Code That Writes Code with Roslyn. And it's just occurred to me, I've done this talk a few times, but it's just occurred to me that even that's not really accurate. It's more write code that reads code with Roslyn, and then use that to write code with C#. But anyway, let's just dive in. And so before we kind of kick off too much, I'm going to put up a Visual Studio. If you can't see the font, if you can't see the text, come this way a bit, because I can't make it much big. If I make it much bigger, then the only thing you'll be able to see is the words package reference. So we're not doing that. Okay. I am Mark Rendle. I am a .NET developer, and I am the creator and maintainer of Visual Recode. More about that later. I'm also just brand new, announced today, a developer advocate for a company called Polyscale. So I have to mention that now, because if I mention that, I can get them to pay me for this hour, which is brilliant. But Polyscale, if you use PostgreSQL or MySQL databases on the web, on the cloud, it's like Cloudflare, but for your database. And so you can connect to your database in an AWS data center, and that database might be the other side of the world in an Azure data center, but you're still getting millisecond response times. It's super awesome, and I'm very excited about it. But that's not what this is about. This is about Roslyn. And Roslyn, the easiest way to describe it these days is in Visual Studio. Roslyn is the thing that looks at your code and tells you you're an idiot and you're doing it wrong, and offers to fix it for you if you press Control dot. I should point out that if you have ReSharper installed, then that's got nothing to do with Roslyn at all. ReSharper doesn't use Roslyn. They have their own C# code engine, and so that's ReSharper that tells you that you're an idiot and offers to fix your code for you. But if you just have vanilla Visual Studio, or if you're using CodeRush also uses Roslyn in increasingly, no, I'm not going to say that. What didn't he say? So yeah, I knew about Roslyn, but I hadn't really done anything with it. And then Microsoft, basically in 2017, 2018, when .NET Core 3.1 came out, and Scott Hunter said, the next version of .NET after .NET Core 3.1 will not be .NET Core 4, it will be .NET 5. Because we're not having a .NET Core 4, because that's just too confusing, even for us. Even Microsoft didn't want that confusing a version number, so they were going to go to .NET 5. By the way, if any of your API, if any of the stuff that you're using in the full-fat, old-fashioned .NET framework has not been ported over to .NET Core, it's not going to be. And that included WCF. And that made a lot of people very unhappy. And Microsoft said, hey, if you're using WCF, then we recommend you go to gRPC. We've got a brand new implementation of gRPC, and it's brilliant. And people looked at their solution. The average solution that contains WCF has over 1 million lines of code in it. Now, to be fair, That's because the same solution contains your WCF application, your Windows Forms application, your WPF application that you started to migrate from Windows Forms but never finished, your Web Forms application, your ASP.NET MVC application, the same thing as the WPF and WinForms applications, and in some cases that I have seen this year, some classic ASP pages, and it won't build if you don't have Visual Basic 6 installed. But there's some WCF code in there. The thing is, though, the WCF code, the code that's actually WCF is just, it's a service contract, and that's got some methods that call into your business logic. And then it's got some data contracts, and those are the things that are used to send messages backwards and forwards. The bit of the solution that is WCF is actually very small. And I thought, I wonder if you could just write something, maybe using that Roslyn thing that I've heard about, that analyzes your service contracts and your operation contracts and your data contracts and generates the gRPC protobuf equivalent. And so I tried that, and yeah, actually that's really easy. And then I thought, I wonder if I could then also write code that maps from the gRPC service implementation and just calls into the old WCF service contract implementation and handles all the translation between the different data contracts versus gRPC messages. And yeah, turns out you can do that as well. And by that point, I'd kind of managed to teach myself Roslyn reasonably well. Because Roslyn is amazing, but what it isn't is very well documented. So the best way to learn Roslyn is Josh Varty has some blog posts which are incredibly helpful. But actually, the simplest way is to dive into the open source Roslyn analyzers that Microsoft have. So all those squiggly analyzers in Visual Studio, they're mostly open source. They're mostly built into Roslyn rather than Visual Studio. And so I taught myself how to Roslyn using those code samples. And I thought, well, I'll try and kind of summarize the key points into a talk. And here we all are. So Roslyn, if you don't know sort of what Roslyn actually is, up until sort of the early 2010s, the C# compiler was written in C++, and the VB.NET compiler was written in C++, and it was becoming extremely difficult to maintain it, and one of the kind of maturity signals for any programming language is the compiler for that language written in that language? They call that being self-hosted. And nearly all languages are self-hosted. So like the TypeScript compiler is written in TypeScript, for example. And the C# compiler still wasn't written in C#. And so they went, we're going to rewrite it in C#, and that will make it work better in Visual Studio, which by then was a WPF application. And we can do it so it'll be a compiler as a service. So we can package up all the different bits of the compiler, the parser and the syntax trees and all that sort of thing, and we can distribute them on NuGet. And so they rewrote the C# compiler in C#, yay, and they rewrote the VB.NET compiler in VB.NET, which serves them right, and they put it all up on NuGet. And so all the Roslyn packages, most of the Roslyn packages start with Microsoft.code analysis. Am I hissing? Why am I hissing? This noise, okay. That. There we go, that's better. Thank you very much. Now I'm going to go just to wind him up. Sorry, mate. Thank you. So yes, and we've got Microsoft.codeanalysis.c#.workspaces, and Workspaces is your kind of top level thing. So your workspace contains your solution, and your solution contains your project, and your projects contain your documents, and your documents contain code. And so the thing that you nearly always need to bring in before anything else is Microsoft.codeanalysis.c#.workspaces. And then there's also Microsoft.codeanalysis.workspaces.various things. And there's an MSBuild, and there's an ad hoc, and there's a Visual Studio one, but that only works if you're working on a Visual Studio extension. The MSBuild one is the most useful one, because that's the one where you can say, hey, see that .sln file there, open that and do your thing. And so that's what we're going to be looking at today. We also have Microsoft.build.locator, which finds the right version of MSBuild that is installed on your machine. So every time you install the .NET SDK, the modern .NET SDK, so .NET 6 or .NET Core 3.1, you get a version of MSBuild installed along with that SDK. Every time you install Visual Studio, you get 2 or 3 versions of MSBuild installed along with that. And you also have the MSBuild that is compiled using .NET Core or .NET 6, and you have the MSBuild that is compiled using .NET 4.7.2. And none of these things work together. And so what Microsoft.build.locator is supposed to do is find the right one that's going to work for your application. So if you include Microsoft.build.locator in a .NET 6 application, it will find the .NET 6 version of MSBuild. If you put it in a .NET Framework application, it will find the .NET Framework version. If it gets that wrong, everything explodes and your projects don't build and nothing works. And then for reasons that I'm really not entirely clear on, you also need to bring in NuGet.projectModel. You just do. So, Workspaces. Go away, Mr. Insect, that's my screen. Workspaces are the top level thing, and you can essentially think of your workspace as being like a virtual, invisible Visual Studio. That's that kind of top level container of all the things. And within your, the types of workspace, you have ad hoc workspace. And this is one where you can just go, create an ad hoc workspace, add a pretend solution to it, add a pretend project to that solution, add a pretend document to that project, and you can muck about with it. Ad hoc workspaces are fantastic for writing unit tests and for sort of messing about and experimenting, and entirely useless for anything else. MSBuild workspace is the one that you'll be using the majority of the time, unless you are actually using the Visual Studio SDK to write an extension, in which case you get the Visual Studio workspace, which is almost identical to the MSBuild workspace. So your workspace has a solution, and your solution has one or more projects, and your projects have documents. And not all of those documents are C# files. They could be JSON files, so your app settings.json, that's the document. And so we have to check when we're going through documents to make sure that they are actually C# documents. So for MSBuild, we have to use Microsoft.build.locator, and we install that package, and then the first thing we do in our program, and I mean literally, like class, program, main, MSBuild locator.register defaults. Don't let it do anything else at all. That's the first thing you do, because otherwise, 9 times out of 10, it will find the wrong one. And then you get your MSBuild workspace, and then you can start loading things into it. So let's jump over to the code quickly, and I will demonstrate that. So here we have our program.cs, and we call MSBuild locator.register defaults, and then we create a workspace using MSBuild workspace.create. And then we set a flag to say load metadata for referenced projects equals true. That, funnily enough, is the thing that needs that NuGet.project model, because referenced projects includes NuGet packages. So if you don't have that load metadata for referenced projects, then it'll only know about your source code. It won't know about and stuff that's in the base class library for .NET. It won't know about anything outside of that. Then we add an event handler to workspace failed, because when the compilation fails, that's where it goes. Because when we say var solution equals await workspace.open solution async, that will always work. It will always give you a solution back. It's just that solution might not have any projects in it, or those projects might not have any documents in it. Because if a document that's supposed to compile doesn't compile, it won't be in the project. But the only way you can know about that is if you've added an event handler for workspace failed. All of this I learned painfully, one thing at a time, sometimes in production. Yes. So, the primary unit of information in Roslyn is the syntax tree. And this is an abstract representation of your code. So we have a syntax tree. A document, if it is a compilable document, will be able to give you a syntax tree. And that syntax tree contains SyntaxNodes. And it's essentially just like a DOM for your code. So you have a root node, and then that has child nodes, and each of those nodes have child nodes. And some of these nodes will be things like a declaration of a class or a declaration of a property. And some of these nodes will be an opening brace or a semicolon. It goes right down to that sort of level. And then we have tokens within that. So a token is something like an identifier. So a node might say, I am a property declaration syntax, and within that node, there is a token, which is the identifier, which is the name of the property. Or it could be a semicolon. Then we have syntax trivia, because we also have white space, and we have commas in lists of attributes, and we have comments and documentation comments. Anything that the compiler doesn't actually compile into intermediate language is called trivia. And if you don't put trivia in, then all your code will be generated as one great big long string, and it'll be completely unreadable like COBOL. There's a brilliant thing built into Visual Studio. Has he got the thing installed into Visual Studio? He asks himself. We go to View here, and we go to Other Windows, and Syntax Visualizer. Very real chance you're not going to be able to see this. But, so, this is the best way to learn about what syntax trees look like and how they relate to actual code. So if you install the Visual Studio SDK tools and the compiler tools as part of your Visual Studio setup, you can go in and modify it and so forth. One of the things it will install for you is this syntax visualizer. And then you can click on bits of your code in your editor window here, and it will jump to that bit of code over in the syntax tree. And so you can see here, if we go up to the top, we've got a using directive there, and that using directive consists of the using keyword, and then it's got some white space after it for just that single space there, and then it has an identifier name, which is an identifier token, which is system, and then it has the semicolon token, and end of line trivia or new line trivia, okay? And so you can go bouncing around. So if you wanted to say, well, I need to find the place in my code where somebody has called new SQL connection, because I want to check to see if they've called using when they create their SQL connection, because I thought it might be a good idea not to leak memory all over the place. More on that at the party this evening. Yeah, you can essentially look at the code that you want to be able to find, and in the syntax visualizer, you can click on it, and then you can read through everything in there and find out where that would actually be in the abstract representation. That's literally all it's for. So that's a brilliant tool. So just to restate it, if you go looking for that and it's not there, you need to install the SDK tools and the compiler toolkit as part of your Visual Studio setup. So you've got your syntax tree loaded in, and there are two main ways that you can work with that syntax tree. And the simplest one is that it has a link API. So if you've used link to XML, where you say element.elements and maybe give it a name, and then you can for each through those, and you can do select and where and of type and all this sort of stuff. And it's exactly the same with a Roslyn syntax tree. So I can say node.descendantNodes.ofType class declaration syntax. And that, if I do that from the root of a document, it will go through and it will find all instances of public class or internal class inside that document. Ideally, it will only find one, because you should only have one class declaration syntax in your application. However, I have metrics. I have metrics that show at least one application that my tool's been used with that had one project, that had one document, that had over 100 classes, all in the same document. And the person, when it did its thing and it copied those classes over to a new solution, it split them all into separate, so a file per class, and the customer reported that as a bug. Welcome to my world. So yeah, descendant nodes, so that's not the same as child nodes. There's a child nodes, which goes get everything at this level. Descendant nodes is all of them. Go down through the entire tree and just find me all the ones that are of the type class declaration syntax. So let's take a look at what this looks like. So here we've got a syntax query demo. So we do this open solution here, and we go to list async. And we get our solution at the top level there, and we say for each, we're going to say solution.projects.select many, and we're going to say project.documents, and then we're going to say await document.getSyntax root async. We say if root is null, continue, because that, if it doesn't return a syntax root, then it means either the compiler wasn't able to make sense of that for reasons probably to do with it having loaded the wrong MSBuild, or it's not a C# document or a VB document. If it's neither of those two things, won't work with F#. There's no Roslyn for F#. That's a whole different set of tools, and I don't know them. And then we can say for each type declaration syntax in root.descendantNodes.ofType base type declaration syntax. So class declaration syntax and struct declaration syntax and interface declaration syntax and enum and delegate, and have I forgotten anything in C# that are types at the top level? Oh, record now, yes. See, I haven't forgotten that. I'm just still living in 2018. So yes, that will find all of those, all the things that come from that. And then from there, we can get the namespace declaration syntax. So we can go navigate back up the tree by saying first ancestor or self, and so go back up the tree until we find something that is a namespace declaration syntax. And then from the type declaration syntax, we can get the identifier.text, which is just the name of the type. And from the namespace declaration syntax, might not have found one. Might be the root file, might just be the program.cs from a .NET 6 application, in which case it won't find a program class because weird things are happening there, and don't get me started. But if it does find it, then it'll give you that there, and then it'll do console.writeLine namespace name.typename. And so if I switch over to my PowerShell here and I make that a bit bigger, there we go. And I do .NET run, and it embarrasses me by, oh no, it doesn't. Next time when I've changed it and it has to build that, it'll tell me I've done something wrong and I don't care. So we can see here that we've got a sample.program and a sample.library.greeter. Thank you very much. Good night. No. So that is one way to navigate through your syntax tree using Roslyn. But that's, it can get quite hairy, sort of writing all those queries and where clauses and whatever else. And also, it's not the most efficient approach to doing this. And one of the things that you can do with Roslyn that we'll look at the end of the talk is you can create your own Visual Studio analyzers and code fixes. And when you're doing that, essentially your analyzer is running kind of like every keystroke. And so you want it to be fast. And the link API is not the fast way of doing this. So this is great for something that's sort of analyzing code on check-in or rewriting WCF as gRPC or whatever it might be. But if you want something that's a little bit more performant and easier to work with, then there is the C# syntax walker. So this is the visitor pattern, except I hate calling it that because there's another class called C# syntax visitor, and you don't want to use that one. You want to use C# syntax walker. C# syntax walker, you give it a syntax node, like the root syntax node from the document, and you say, there you go, visit that. And what you're actually saying is walk that. And it will go through all the nodes, and then it will call visit class declaration every time it finds a class declaration syntax node. And it will call visit interface declaration and so forth. That is the visitor pattern. C# syntax visitor will only walk to one level. As soon as it hits something, it'll go, I found it, and now I'm stopping, which isn't really the visitor pattern as I understand it. So the one that you want is C# syntax walker. And so we have a demonstration of C# syntax walker, and for some reason, we've used syntax visitor. I'm going to rename that just because that's terrible. There we go, syntax walker demo, much better. Right. So in here, we create a new list types walker, and then we have our for each through our documents and everything else, and then we call this walker.visit. And if I go to my list types walker, you can see here that we have visit class declaration and visit interface declaration, and then we have this write method down here that essentially does the same thing as the link code was doing. The important thing here is that when I override these methods, I have to call that base method. If I don't call that base method, then it stops. So if there's a class declaration nested inside my class declaration, it won't find it. So what that base method does is essentially say, and continue walking. And this is one of those things where I thought I should do a talk, because that's not intuitive. And if you go onto Microsoft Docs and you look at the documentation for visit class declaration, it says visits a class declaration. And that's it. And seriously, I love the Roslyn team. They've built something amazing, and I wouldn't have been able to do a bunch of the stuff that I've done without them, and I wouldn't be here giving this talk. But they use bloody GhostDoc to generate their documentation. And yeah, so you have to call that base method. And this is fantastic, because this essentially, let's just do a Control-Shift-S. And so if I go out to here and do .NET Run, there we go, got some build warnings, and exactly the same thing happens. And it took 7 seconds, but that included the build. So yeah, exactly the same thing. You just have to trust me when I say that it used less memory and less CPU to do that, and therefore it is better. Okay. So we can walk syntax, and you can literally just kind of do use IntelliSense, and you can see if you put syntax, it'll just show you all the types that end in syntax, which is basically everything. I actually learned, I can't remember what it was, but I distinctly remember I learned that a C# feature existed because I saw syntax for it when I was working with Roslyn, and I was kind of like, what the hell is that? And yeah, it was, it's everything is in there, record syntax and all this sort of stuff. But it's really difficult to make sense of what all that syntax means by yourself. So for example, let's say that I see the word string. Well, there's a type, string. Now it's got a capital S, so it's possible that someone's just written capital S string instead of the keyword string, in which case I should be writing an analyzer that fixes that for them, because you shouldn't do it. The keyword string, though, shows up as the same type as if you had system.string. But could it be that I'm actually going through the WCF application for a company that manufactures, distributes, and sells string? Possibly. So how do I know if this string is... And this is up at the top of the class there. I've got using system, but I might also have using stringco.stockcontrol.models. And there might be something else, and I don't want to have to bounce around all over the place trying to work out from the syntax whether we're talking about a string of characters or string for tying up your Christmas presents. I had a conversation with my wife once, and I was just going, just the string handling's so bad. And she looked at me and she went, the what? And I went, the string handling in this application is terrible. And she went, why is the application handling string? And it occurred to me that to the kinds of people that we're not, that's not what string means, which makes it even more terrifying that when I go onto Google and search for string, it takes me to the Microsoft documentation and not Amazon. And I know that's terrifying because I'm trying using DuckDuckGo for a month, and when I put string in DuckDuckGo, it takes me to Amazon. So anyway, making sense of what these syntax tokens and nodes and everything actually means is where semantic models comes in. So the semantic model is the combination of the syntax tree and the in-memory compilation of the code. And so there is a semantic model, and for every point in the syntax tree, you can go, give me the bit of the semantic model that is what this syntax means. And that is where Roslyn gets really clever, because that is where you can go, okay, I have a type here, give me this type information, and then I can say, is this system.string or stringco.stock.string? And so semantic models, you don't compile documents, obviously, in C#, you compile projects. And so we create a compilation by saying await project.getCompilation async. We will always get something back off that. It may just be full of errors. So this tends to work best with code that does compile, but it'll give it a good try with code that doesn't. And then we can get a semantic model from that by saying await compilation.getSemanticModel. That should say async, sorry, from the semantic tree, which we've got from our document. So our document goes, here is all the code represented as a syntax tree. And then we throw that to the compilation and we go, give me the semantic model for this syntax tree, and it gives us back our model. And within that model, where in the syntax tree we have nodes, and the nodes have tokens and identifiers and trivia, the semantic model has symbols. And so let's say I've got my, from this test application that I've got here, I've got a greeter, and that's a class declaration syntax that is called greeter. And so I can get the symbol info from that by saying model.getSymbolInfo and passing in that identifier name syntax. And then that will give me an I-named type symbol in this particular instance, and then I can get all the information about that from that semantic model. And this works with everything. So an awful lot of stuff that comes through in C# is an expression syntax. So x equals 42 is an expression syntax. That's an assignment expression, but it has a return value. I++ is an expression syntax. It's a unary expression, but it has a return value. And I can get the type of that expression, which is insanely useful, because it means that I can I can sort of work out, if I look at a method, and then I look at all the expressions in that method, then I can find all the types that that method needs to work, which is super helpful. So let me just go back to here, and we'll just check. So here's my symbol demo. And so we're going to say, go through each project, and for each project, get the compilation, and if the compilation is null, continue. So I said compilation will always return something. It won't necessarily always return something, because one of the types of project in a solution is a solution folder. And so you might have a solution folder that's just got like your Docker files and your readme.txt. And so if you call get compilation async on a solution folder project, you'll get null back. And then we go for each one of those, of the documents in that project, get its syntax tree, and if it hasn't got a syntax tree, then carry on. Then get its semantic model. Then we get the root out of that tree. And then we can say for each type declaration syntax in root descendant nodes.of type, get our base type declaration syntax. Then we can say get the declared symbol for this type declaration syntax. That should always return an I-named type symbol, but sometimes it will return an I-error type symbol, which says it's there, I kind of know about it, but I can't make sense of it. And then we can write our type kind, which is class or interface or struct or enum. And then now we have that thing about, we don't have to go find ancestor node namespace declaration, because this I-named type symbol, once you get to the point of working with this, it's really nice because it looks almost exactly like type from the .NET framework itself. It's just you're doing it at design time with the code rather than at runtime with object.getType. But it's pretty much it maps directly, even if it doesn't use the same words for everything. So we have symbol.containing namespace and symbol.name, and then we can say symbol.getMembers.ofType method symbol. So there's no get methods, or get properties, or get fields. It's just get members, and then you can say of type I method symbol. Or once you get fed up with doing that, you can write 3 extension methods called get properties, get fields, and get methods. And then for that method symbol, we can say it is implicitly declared, and if it's not, we can write out the symbol name like that. So now if we run that again, so yeah. So you can see we have a class called sample.program, and that has a method main and a method askName, and we have a class sample.library.greeter, and that has a method called .setor, which is the constructor, and it has a method called greet. That is implicitly declared. That's kind of important because a lot of these classes have implicitly declared methods. They all have an implicitly declared static constructor that does nothing. If you haven't specified a parameterless constructor, it will have an implicitly declared parameterless constructor, unless it's a static class, because all classes have to have a constructor. If you've got properties on there, then it will have implicitly declared get and set methods for those properties. And if, God help you, you've got an async method on there, it will have like War and Peace of implicitly declared types and methods and fields and state machines and Lord knows what else. So basically that, on all these symbols, there's an is implicitly declared method that basically says, did I write this? Or did the C# compiler write this? Because if the C# compiler wrote it, I don't care, I don't want to know about it, just keep it away from me. It's a brilliant website that I use a lot called sharplab.io, and you type in some C# code, and on the right-hand side, it will show you the C# code that the C# compiler generates for the C# code that you wrote, which includes things like async state machines, and then it will show you the IL code that's generated, and then if you give it a target platform, it will show you the machine code that it generates for like Windows x64 or Linux x64. So yeah, so we found all the methods, but we can use this to find all the used types in this entire solution by looking at the expressions within those methods. So if we go back to here, and we're going to use, oh no, we've got a symbol visitor, which I tend to skip over. So we have a list types visitor here. So in the same way that there is a C# syntax walker, there is a symbol visitor. I'm going to mention it because it's there. And if you know it's there, then you might sort of go and explore it and you might use it. And if you use it, you might find out what it's for. And if you do, can you please email me and tell me? But it's there. It's another way that you can go through all the types. So this will actually let you go through all the types in a solution, this symbol, all the symbols in a model, without worrying about the syntax tree at all. And I have never found a useful use case for that, because it's the syntax that you kind of really care about. It's not the symbols. The symbols give you information about the syntax, but never mind. So that is there, but I'm going to skip over it because it takes time. But finding all used types. So if we go back to here, and we can go into the dependencies demo, and we can go into list all used types like this. So I'm going to pass in a solution, and we're going to create a new set of types, which is just going to be a hash set of string, which is going to make sure that we don't list the same type twice. We're going to go through each of our projects. We're going to get our compilation, make sure we got a compilation, and then we're going to go through our documents in our projects, and then we're going to do another thing. We're going to say if document.is auto-generated. And this has become even more important recently, and I need to update this, probably. In the same way that your classes have implicitly declared fields and methods and that sort of thing, your project has implicitly declared or generated documents. So for every XAML file in a WPF application, there's a generated.g.cs or .xaml.cs for that XAML file. These tend to have .designer, .generated, .g or .gi in the file name, but not reliably so. And this is just the ones that Microsoft have done, by the way, never mind sort of third-party things. Also, if you've got source generators in there, then those throw stuff in. And one of the things that they say in source generators, which is not in this talk, but I'm writing a whole other talk about source generators, is that you should put .g.cs as the file name for the generated source. Or sometimes you get temporary generated file underscore that goes in there as well. And then we also have this begins with auto-generated comment. And this is quite useful. So we can say if we've got this root syntax node, if it has leading trivia, then let's go through the leading trivia and find if it's a multi-line comment. So that's a comment that starts with /* and ends with */, because one of the nice things that everybody always does when they auto-generate a file is put a multi-line comment at the top of the file saying this file was generated by a tool, as opposed to some of the stuff in source control which would say this code was written by a tool. So yes, and then we can look there and we can just see if it's got the words auto-generated or auto-generated. This catches, honestly, probably about 50% of generated code, but it's better than nothing. One of the things it does catch in .NET Core or .NET 5.6 applications is the auto-generated assemblyinfo.cs file that goes in there now, because that's now auto-generated from CS proj. But that does have the leading comments, although I believe it is still just called assemblyinfo.cs. So in our dependencies demo here, we say if it's an auto-generated document, just crack on because I don't care about that. Then we're going to say you get the syntax tree from this, and if that's null, then we can continue on. Then we'll say get the semantic model for that, and then we can say get the root syntax node from that tree, check for that auto-generated comment at the start, and then we have this getTypes method here, and we're going to pass in our root and our model. And here, we're going to properly get our link on. So we're going to say descendant nodes dot of type identifier name syntax, and then we're going to say model dot get symbol info in there, and then of type inamed type symbol. So identifier name syntax is a variable name, which could be in a method, or it's a field declaration or a property declaration or a parameter declaration in a method. This will find all of those, and then we get the symbol info for that identifier, which will tell us what kind of identifier that is. And then for the ones where it is a known type, then that will be an inamed type symbol. So that gets us all our variables, our parameters, and all those sorts of things. And then we can do the same thing again, except this time we're looking for expression syntax. And so this gets us things like somebody might have called a method and passed in 1024 times 1024 as an expression because they couldn't be bothered to do the maths to work out how many bytes there are in a megabyte. And so expression syntax will find 1024 times 1024, and the type of that will just be int. And so we get our named types that are from our identifiers and our expression types that are from expressions within the code, and then we push them all into one enumerable here, name types and expression types, and then we call distinct on that. And distinct, those yellow lines that keep coming out when I do that run thing, is symbol equality comparer dot default. And now that isn't going to build at all because it won't let you do that. Named type symbol equality comparer dot instance. So yeah, I use named type symbol equality comparer dot instance, and I still get the warning saying use symbol equality comparer when comparing symbols. I am. It bothers me that that's an analyzer written by the person who wrote the thing that writes the analyzers, and it's quite clearly telling me something wrong. Anyway, let's just do a save on this, and then we can come back out to here and we can do a .NET run again. And it takes it a while. But yes, so it started off with the main application, and the first thing it found in there that was used was system.library.greeter, because it creates an instance of greeter. But it's also found usages of system.boolean, char, console, int32, string, and void. Void is a type, and I always forget that, but the return type of a void method is not, it's system.void. And you know you messed up when your protobuf generator, you sort of didn't write the tests properly and you release a new version of your project, and then someone comes back and goes, my protobuf compiler is giving me errors saying system.void is not a known protobuf type. And you're kind of like, shit. Maybe roll back to the previous version while I fix that. So yeah, system.void is a type. Okay. So now we can understand code, we can read code, we can look at code, we can go hunting for patterns within code, we can write link queries, and we can write walkers, not visitors, walkers against our code. So now we get to the interesting bit. Can we rewrite code? And you're not going to automate yourself out of a job by doing this, by the way. But what you can do sometimes is, let's say you're upgrading to a new version of a NuGet package or a new version of .NET, and there's a better way of doing something now, and your team lead or somebody who hates you says, can you go through all the code and change all of these things to use this new way of doing something? Or more likely, can you go through the code and change them to do this the company approved way of doing something? Because, you know, if it's like, can you go through, some people don't like the var keyword because it makes code reviews difficult. And it's kind of like, if you find that makes code reviews difficult, personally, I don't want you reviewing my code, but never mind. So somebody might say, oh, we never use the var keyword, never, ever, ever. Now, that's actually quite easy to fix. You can sort of alt-enter with resharper and just say, go through the entire solution and just replace var with the actual type of whatever it is. As if your manager doesn't know about resharper, then you can take the rest of the week off. Just make sure you commit it kind of a few files at a time and write a Python script to do pushes every 2.43 hours and go to the beach. Hire me. People go, oh, do talks for exposure. And it's kind of like, yeah, no, really, I can't, I know. So yeah, we want to rewrite code. But yes, you can use this to automate incredibly boring bits of code. But it becomes interesting. It's challenging, because one of the things with Roslyn is everything in there is immutable. So the thing that you can change is the syntax tree. But you can't change a syntax node. You can only replace it with another syntax node. And when you replace that syntax node in a syntax tree, it essentially invalidates that entire syntax tree right the way up to the root node. There is now a completely new syntax tree with that new node in it, and the old one is dead, and you've broken it. So the syntax tree is immutable. So you think, all right, well, I'll just go to the document and I'll set the document's new syntax, set document syntax tree equals this new syntax tree where I've done this thing. Document's immutable as well. So now you have to go back to the project and say, hey, project, replace this document here with this new version with the syntax tree that I updated because I added a new line character somewhere in the source code. Except it turns out project is immutable as well. I say, all right, so I go to the solution and say, no, solution, that's immutable as well. So the point at which it stops being immutable is the workspace. And so what you do is you change your syntax node all the way down in the code over here, and then you come back all the way up to the top here, and you go workspace.apply changes, and then workspace.save, and it'll write everything out that changed, which is lots of fun. And you think about doing that, let's say, well, let's just use the example I'm about to show here. I want to go through, this is more like an April Fool's joke that you might play on somebody. I want to go through every string instance anywhere in this entire solution, whether it's a literal string or the returned value from a method or a property or whatever it might be, and I just want to add toUpper invariant on the end of it. That's the kind of nice version. The nasty version would be to add a .replace, like the time I hacked my wife's Microsoft Word to replace any references to Margaret Thatcher with that bitch. Would probably have been okay, but she worked for Margaret Thatcher. Okay, so yes, what things in Roslyn were immutable? Everything. Solutions, projects, documents, syntax nodes. So you think if you've got like 1,000-line class and you want to go through and replace every syntax node in there that is a string with a new syntax node that is basically that syntax node but now with .toUpper invariant tacked onto the end of it. And so I've changed one. So now I've got to go back up to here and I'll start again. And then now I changed, hang on, no, I've just changed the same one, and now it says .toUpper invariant, because it is at least deterministic, and I'm hitting the same string expression every time. How do I keep track of which? So, and fortunately, the team realized this, and so they gave a C# syntax rewriter And this is almost exactly like C# syntax walker, except instead of returning void, or system.void, these methods return a syntax node. So they look at the syntax node, and they say, do I need to change you? And if I do, here's a new syntax node with those changes, and I'll return that. And if I don't, I'll just return the node as it was passed in. And this lets us take care of all those nastinesses around immutable code. So let us close all but this, and we will go to here, and we will go into rewriter demo.upshift all strings. So, go through all the projects, get the compilation, do the blah, 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 make sure it's not auto-generated because we don't want to do that, get the semantic model. Now we have a new string literal upshifter. And so this is a C# syntax rewriter, but we're going to pass in our semantic model so that we can use that to make sure that we're upshifting text and not balls of string from stringco's stock control system. And then we just have visit literal expression. This is one of the things that we can override in here. So we're only going to find the hard-coded strings with quote, quote around them. We're not going to do this on everything. So in visit literal expression, we can say if model.getTypeInfo of node.type is iname type symbol type, if type name equals string. Now, I could stop there because if it's a literal expression and it's a string, it's system.string because you can't have literal expressions for anything else. But C#12 maybe, possibly C#13, you know, it might be C#27. At some point, they're going to put UTF-8 string literals into C#. And then to upper invariant might not be available, because what does to upper invariant mean on a string that consists entirely of emoji because it's an Elon Musk business tweet? So let's just belt and braces, as we say in Britain. We'll make double sure. We'll just say, give me the members of this and make sure it's got string.toUpperInvariant in it. Make sure it's got that method, because I don't want my April Fool's joke to result in my friend's program not compiling, because then he might not deploy it into production and hilarity might not ensue. Okay, so then in here, we can now use a syntax factory. And so this is where we write code that writes code. So we can say, create an invocation expression. So that's essentially a call, a method call. So we're going to invoke, and then we have a member access expression to say we are accessing a member on this field. And then we have our syntax kind is simple member access expression, so string.toUpperInvariant. That dot, that's a simple member access expression. And then the node, which is whatever that string literal was in the first place. And then on the end of that, we're going to add syntaxFactory.identifier name of string.toUpperInvariant. Now, the other thing I could do in here is I could get the text of that node, and I could put it in a string, and to the end of that string, I could concatenate dot to upper invariant, open parens, close parens, and then I could use syntaxFactory.pass to turn that into a syntax node. That works just as well, and in an awful lot of cases, that is the easier way to do these things. I'm just using this to kind of demonstrate. I'll show you an example of the syntaxFactory.pass later. There are people who say, if you are generating C# code, you should do it like this with Roslyn to make sure that you are generating C# code correctly. I am not one of those people. For the most part, I say, if you are generating C# code, generating it, not modifying it. If you're generating an entire C# file for whatever reason, then just use a string builder. Use an indented string builder for sure, but use a string builder, because this, it's really invocation expressions and member access expressions and all this sort of stuff, and that is literally, we're just going add dot to upper invariant to the end of whatever's already there. So yes, but you can do this like this. So if the type is type and if the thing is a string, then we are returning this. So we're returning our brand new syntax node that includes our old syntax node, and then C# syntax rewriter is going to take care of working out which node it passed in and which node has come back out, and then at the end of this whole process, when it's visited all the nodes in this tree, it will call replace nodes and pass in a bunch of tuples saying replace this node with this node and this node with this node and this node with this node. And you will get something out where a whole bunch of nodes have been replaced. And then we can say, so we say new root equals upshifter.visit root. And then syntax nodes have a dot is equivalent to. And dot is equivalent to basically says, is this syntax tree equivalent to this syntax tree? Annoyingly, that will return false if you've added some white space or other things that don't bloody matter. You can hack around that, but I'm not going to here. But if it's not equivalent, then we literally say new solution equals new solution dot with document syntax root, and we pass in the document ID here, and we pass in our new root, and it finds where that document ID is in the existing solution, and it replaces that document in that project with this new document with our new syntax root. And so that is how you work with the immutability in Roslyn. It's fun, right? It is. For me, the really great thing about this is it means that writing visual recode is hard, and so it puts other people off from doing it. That's really what I'm doing here, is I'm going, look, you can do this, but it's so difficult, please don't. God, I sound like Eddie Murphy when I laugh. Or possibly Stampy. Anyone's kids watch Stampy Longnose on YouTube? Lucky. Okay. So then we get to the top, and we can say, have we made any changes? Because there's an entire chance that there are no string literals anywhere in this thing. And if there aren't, then we don't want to do this. But then we say workspace.tryApply changes, and we pass the new solution in. One of the nice things that will happen at this point is that if anything else on, say, another thread has changed the solution since the solution that we based this on, so if you've got like a conflicting thing, then it will try and apply the changes from this new solution and do a sort of git merge in memory. But if somebody else has changed it, it'll just go, no, sorry, yours is out of date. I can't make sense of it. You changed the same documents that they changed. That's not going to fly for me. Go back around to the top and essentially do it again. And hope that eventually nothing else on any other threads is going to do nasty things. So if we go over to code here, and we just go bang, 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 bang. So we got our greeter here, which is going to return hello underscore name. And we've got what's your name here. This is essentially the C# version of the very first program I ever wrote on a Sinclair ZX81 in 1982. But yeah, it's also the first program that I showed my daughter how to write. And she's now building games with Unity, so that's fun. So yeah, if I go back to here, and we go into programs, so we're on upshift all strings, and we do .NET run. One change is applied. That's interesting. There were 2 strings. Mark, your demo's broken. It hasn't worked. No, it has. So, yeah, there you go. Console.writeLine, what's your name? .toUpper invariant. So it found that string literal and it replaced it. And then in greeter.cs, and I have, honestly, I've done this on purpose because this caught me, again with released software. $hello underscore name is not a string literal expression. It's an invocation because it's actually underneath, it's being turned into an interpolation method and a call to string.format or whatever it is. So yeah, if you wanted to stick .toUpper invariant on the end of that, you would have to be catching that separately. And I'm not going to tell you how. You can do that as an exercise if you ever actually use anything you've learned in this workshop. Okay. So, there are uses for this around change all the way we do this in the entire solution, and I expect it to take you 6 weeks. Aha! 1 half day, write Roslyn thing, start it running, set git thing, go to beach. But the thing where it's really useful is for writing analyzers. That's the place where you can most easily put it in. And Roslyn analyzers can be used in 2 different contexts. So you can publish them as a Visual Studio extension, and then they'll run on anything that's opened in that instance of Visual Studio. But you can... It's the end times, run! You can also publish them as NuGet packages, and then when someone installs your NuGet package, the analyzer becomes active just in that project that they've got that installed in. So, for example, if you use XUnit for testing, XUnit puts squiggles. So if you use theory and inline data, and the number of things in the inline data attribute don't match the number of parameters to the method, that's the XUnit Roslyn analyzer that's noticing that for you. So they're super useful for that. They're super useful if you've got a shared library that you're using throughout your organization, then you can put in analyzers to make sure that people are using that properly as well. And I have worked at companies that have internal NuGet packages, and it became a best practice to sort of put a Roslyn analyzer alongside your library package just to make sure that people were using it correctly or to make it easier for them to use it. And one example of this was I was working for a bank, and I went through and I added system.diagnostics.diagnostic source all the way through this WPF application. And they went, this is great, and we want more of this, and we want everybody to be able to use this. And so this code sample here is wrong, okay? Because this is just saying, I've got this diagnostics field here, and that sets something, and I'm just going to call diagnostics.write, which means I'm going to create this object here, this new a equals 42, every time we come through here, even if nothing's listening on that diagnostics listener. So if there's nothing at the other end, I'm still creating an object that's coming through here. And we had this in stuff that was running 100 times a second because this was a trading system, and it was just going bang, 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 get the stock update, get the stock update, get the stock update. And so what you're supposed to do is say, if diagnostics is enabled, then do the diagnostics.write. So you don't incur the overhead. And this was really important because we wanted to put this everywhere in the application, but we only wanted it active if we turned the listener on with a line in config on a particular desktop machine. We did not want that overhead of creating objects and doing measuring and everything else. Sorry? 5 minutes. Yeah? Are we supposed to have finished? I thought we finished at 3:20. Fuck me, I talk. I am so sorry. I thought we Anyway. God, I am so sorry. There's a diagnostic source analyzer. Oh! I am the worst person in the entire world. What I'll do is I'll tweet that with the NDC Porto hashtag, and you can go and look at it and maybe come and find me and ask about it. Honestly, I've been looking at my watch, been quite happily looking at my watch going, oh, I've got 5 minutes. I'm really sorry. Go and grab coffee and do the things and have fun. And yeah, I'll be back in here in an hour doing the .NET Rocks Live, and I'll do stuff at the party and everything. Thank you very much for coming. Sorry for running over, and I'll see you again.